All right, now for the final little bit of chapter 2. We're going to talk about graphical techniques. And graphical techniques are important not because we use them so much as working physicists, because we don't. We use computers all the time. Um, but because you'll see them on standardized tests. So this is one of those few times where I go out and I say, okay, I'm going to cover this because this is a technique we see on standardized tests. On the other hand, it's not a bad idea. So sometimes it's easy to get lost in the numbers and get lost in using a computer to calculate things. And it's not a bad idea to actually go ahead and develop the intuition for what the graphs mean. Because intuition for what the graphs mean can be very important in just sort of getting an overall grasp of a problem. So when we look at graphs, first, when we look at x is velocity times time plus some initial distance, that's exactly like this equation y equals mx plus b that you learned in algebra 1, who knows how long ago, right? And you looked at the slope as the rise over the run, or the change in y over the change in x. Whoa, look, doesn't that look familiar? Velocity is the change in x over the change in time. All right. Turns out velocity is nothing other than the slope of position versus time. So you can take this and you can plot the slope at different points and you can get out the velocity, right? You can get the velocity. Or you can take a table like this and you can say, well, I'm going to take 338 minus 200 meters and 5 minus 0. I'm saying divide, that's 138 divided by 5. That gives me my velocity, right? You can take the data, you can do it. You can take the graph, you can do it. Just like velocity is change of position over time, acceleration is change in velocity over time. So we can take a drawing, a graph of velocity versus time, and we can look at the slope at different points and say, oh, if I look at the slope here, if I'm saying, all right, I'm going to take this, I'm going to look at the slope here, right? And yes, I can't draw very well, but I'm going to look at the slope there, and I'm going to take, all right, what is that delta v? And what is this delta t? And that's going to tell me the acceleration right here at this point. All right? So we can use graphical techniques to figure out the acceleration in different places. Now, here's the great thing about having this, doing this sum and getting the feel for it, is when I look at this, I know, oh, velocity is slower, velocity is higher. I know the velocity is increasing because I know the slope is increasing. Here, the slope is higher. The acceleration is higher here than it is once you get up here because the slope is changing. I know the acceleration is higher here, lower there. And that tells me something just by looking at the graph. All right, that's it for chapter 2.